In this video, we will learn about experimental design diagrams. Here's an extra example for review before we actually do the problem, the real problem I want to do, the test question. So look at this side problem. A drug company is developing a new drug called Illuminol, which they believe can temporarily decrease your IQ. Decrease your IQ. Increase your IQ. Okay, I guess sounds like I need some Illuminol. To test the effectiveness of Illuminol, the drug company will run a series of experiments, each with 200 subjects. The experiments will measure how people perform on an IQ test after taking Illuminol and compare this with how people perform on an IQ test after taking a placebo, a fake pill that doesn't do anything. So there are three designs that we have learned about. One is completely randomized. That's just your basic experiment, which the other two are sort of based off of. And the next one is called matched pairs, and the third one is block design. So just taking a look at your completely randomized design, you start with the total number of subjects that you have, and then somehow they get divided up into groups, the number of groups based on how many treatments you have. But how do they get into those groups? Are they divided by gender, male and female? Are they divided by age? Are they divided by race? Well, in almost every case, we want to divide them randomly. And of course, this type of design is completely randomized. So this has to be here, saying that the subjects get put into groups randomly. So the order matters. Then you say what treatment each group is going to get. So group 1 gets the Illuminol, group 2 gets the placebo. Don't make the mistake of combining both of these into one box. I've seen students do that. Just make a box for the groups, and then make a separate box indicating the treatments. And then at the end, you want to say something about what you're comparing. Be specific. Don't just say compare results. Mention what the problem is about. In this case, we're comparing IQ test scores. It could be blood pressure or something like that. All right, now let's compare this to the matched pairs design. So it looks very much the same as the completely randomized design. However, in this case, each group actually gets both treatments, one after another. So every subject gets the Illuminol, and they take the IQ test, and then maybe a week later, they get the placebo and take the IQ test again. Now the reason why everyone is getting both treatments in a row is because for matched pairs, you're not comparing group 1 to group 2. Instead, you're comparing each subject with themselves. That's what same subject means. So if Jerry is in the experiment, Jerry is going to take the Illuminol and see how his IQ turns out. And then he's going to take the placebo a week later, see how his IQ turns out. And then we're going to compare. How did Jerry do on the Illuminol compared to how did he do on the placebo? And to make that clear, we have to say compare same subject IQ results. That phrase needs to be in there. So why have two groups at all? Well, notice that group 2, the order is reversed. Take the placebo first and then the Illuminol. That's important because, for example, in the case where first Jerry takes the placebo, and then a week later he takes another IQ test under the influence of Illuminol, and you find out that Jerry did better. His IQ was much higher with the Illuminol. Well, wait a minute. We're not sure if Jerry did better because this time he was on Illuminol, or maybe he did better because this is his second time taking an IQ test. So maybe he's getting more practice at this type of question. Maybe he's getting better at taking IQ tests. So that's why you want to do it both ways. If Jerry if you have one group of people who are taking the Illuminol second, and their IQ scores are generally higher, but then another group takes the Illuminol first, and their IQ tests are still generally higher, then we can be sure that it's really the Illuminol and not just the fact that it's their second time. So that's matched pairs. The final design is called block design. And if you compare block design with the original completely randomized design, it's the same thing except there's two of them. And that's because if we know that there's a variable that's going to react differently under a certain treatment, for example, if we know that Illuminol has a much greater effect on younger subjects rather than older subjects, then we might treat age, or could be gender or anything, as a blocking variable, meaning instead of just having those different types of people all mixed together, you'll basically run the experiment twice. In this case, we used age as a blocking variable, so we had older people in one group, people over 40, and we had younger people in the other group. So we did basically one experiment with the older people, a completely randomized experiment, and then we did a separate experiment with the younger people. So this is called a block design. Again, it's exactly the same as the completely randomized design. Everything was the same, except for there's two of them, and you should put a box at the very beginning showing the total number that you started off with, which is the same 200 that we used on the other two, but this time we're splitting these up into over 40 and under 40. So I'm going to have 100 and 100, and then we'll have 50 and 50 in the smaller groups. Notice that this is not one big block. Some students want to make one giant random assignment block between them. No, that's wrong. They have to be separate. Okay, all of this has to be separate, so don't join these in any way other than the original 200 subjects. Also, a few students are tempted to put random assignment right here. That would be wrong, because we are not randomly assigning these subjects to these two groups. We're specifically putting the ones over 40 in this group and the ones under 40 in this group, so that is not random. Okay, so in this example, Phys Laboratories realizes that their new drug may affect men and women differently. So they conduct a new experiment with 20 men and 20 women to see if there's a difference in pain relief based on gender. Each patient will be treated and asked an hour later about what % of pain relief did you experience. Outline a block design for this experiment to compare the new drug's effectiveness with aspirin. So let me be clear. We're talking about two separate treatments. We're talking about a new drug and aspirin. Those are the two treatments that are being compared with one another. But they say they want a block design. That's the design where you're going to split up the participants into two different categories and basically run two parallel experiments. So we're starting off with 40 subjects altogether. All right, that's 20 men and 20 women. But immediately we're going to separate those 40 subjects into the two groups, men and women, 20 men and 20 women. Notice there's no random assignment here. They're being separated by gender. So it should not have a block here that says random assignment. All right, but now, okay, we're going to take these 20 men and we're going to separate them into groups. But how are we going to separate them? We're going to separate them randomly. And the same thing is happening down here with the women. All right, I know there will be two groups because there are two treatments, new drug and aspirin. All right, so the 20 men will be randomly assigned to two groups, And so group 1 will have 10 men, group 2 will have 10 men. And same down here with the women, with their own separate experiment. Now each group, of course, will get a treatment. So let's say group 1 gets the new drug and group 2 gets the aspirin. So group 1 new drug, group 2 aspirin. Again, some students wanted to combine these, and they would just put one block saying group 1 new drug, 10 men, all in one box. These should be two separate things. And then at the end we want to compare. Okay, but we want to be very specific. We're going to compare pain relief, right? At what % of pain relief did you experience? So we are comparing pain relief. So this is how the block design should look. All right, this next example always sounds vaguely racist to me when I read it, but I'm sure they mean well. But mostly I need you to know that I did not make up this question. Apparently there are these tests that are made for Mexican Americans that are designed to measure to what degree Mexican Americans act and think Mexican, or to what degree do they act and think white. Now, they use more polite terms in this paragraph. They're very politically correct and it's well written, but students trying to do this problem, it might be just mind-boggling to understand what this paragraph is saying. Basically, there's a test designed to be given to Mexican Americans to judge to what degree they act and think Mexican and to what degree they act and think white. Now, what it means to act or think Mexican versus white, I don't even want to think about that, because that's what makes me feel a little weird, little racist. So I'm just going to gloss over that part and get to the experimental design. So there are two different tests that are being compared in this experiment. There's the bicultural inventory, or BI, and there's the acculturation rating scale for Mexican Americans, the ARSMA. So those are the two treatments that are being tested. Now we're asked to do a matched pairs design for this study. So that's the one where each group gets both treatments. So each group is going to wind up getting the ARSMA and the BI. So let's work on that. So the problem says we have 22 Mexican Americans that we're going to participate in this experiment. So let's see how we design this. Let's start with our 22 subjects, our 22 Mexican Americans. Now they need to be divided up into two groups, but how are we going to divide them up? We will divide them up randomly into two groups. So we're going to have group 1 and group 2. Of course, group 1 will have 11 subjects and group 2 will also have 11 subjects. Now, each one of these groups are going to wind up getting both treatments. Okay, so group 1 is going to get the BI test first, and group 2 is going to get the ARSMA first. But then group 1 is going to get the ARSMA test, and group 2 is going to get the BI test. So both groups get both tests, just the order changes. And that's really all there is to it. And then in the end, we're going to compare. But we have to be very careful how we word this. And there's a specific phrase I really need to see, and that specific phrase is same subject. Or you have to say something about comparing each subject to themselves. But this is a shorter way to say that. But you can't leave it out. Because the idea is, unlike when we did a simple random design, we're not comparing group 1 and group 2. So even though we have a group 1 and group 2, we're not comparing those. We're comparing each person with themselves. Okay, so same subject. So you can't leave out either one of these words. Some students wanted to say compare same test results. No, you're talking about the same person, same subject test results. You can't leave any of those words out. So that is how you design a matched pairs design for an experiment. Okay, can I fit these both on the screen at the same time? Not really. That's a fail. All right. Peace.